Something was photographed on the moon decades ago, something that had no rational geological explanation. The images were real, the coordinates were precisely logged, the data was transmitted back to Earth through official NASA channels. And then, quietly, without announcement, without press conference, without a single public statement, those images were reclassified, pulled from public archives, replaced with versions that looked subtly, carefully different. No journalist investigated, no senator asked questions. The scientific community moved on, almost as if they had been told to. And the one thing nobody is talking about, the question that has haunted former NASA insiders, independent researchers, and a growing number of credentialed astronomers for more than 50 years, is devastatingly simple. What exactly did we find up there? And why did they decide you were never supposed to know? There's a moment in every major cover-up, and history has shown us enough of them to recognize the pattern, where the silence itself becomes the loudest signal. It is not the missing documents that betray the secret. It is not the redacted files or the classified briefings. It is the strange, coordinated institutional quiet that descends over a subject the moment it becomes too dangerous to discuss openly. That silence, when it surrounds something as vast and as publicly funded as the American space program, is not an accident. It is architecture. And the silence around what has been found on the lunar surface is, by any honest measure, one of the most structurally elaborate silences in the history of modern science. To understand what we are really talking about, you have to go back to 1966, not to Apollo, not to the famous moonwalks that were broadcast in grainy black and white to a world holding its breath. You have to go back to a mission that most people have never heard of, executed by a spacecraft that most people have never seen referenced in any mainstream documentary. The Lunar Orbiter program, 5 unmanned spacecraft launched by NASA between 1966 and 1967, was designed to photograph the lunar surface in unprecedented detail. The official mission objective was straightforward: map safe landing zones for the upcoming Apollo missions. That was the cover story. The real function, as declassified documents have since confirmed, was intelligence-grade photographic reconnaissance of the entire lunar surface. And in the process of conducting that reconnaissance, Lunar Orbiter 2 captured something that stopped the mission scientists cold. On November 20th, 1966, Lunar Orbiter 2 transmitted a series of photographs taken over the Mare Tranquillitatis region, the Sea of Tranquility, the same region where, 2 years later, Neil Armstrong would take his famous first steps. Within those photographs, a cluster of objects appeared, 12 spires, rising from the lunar surface in a nearly symmetrical arrangement. The largest of them, according to measurements taken directly from the photographic data, stood approximately 213 feet tall. The shadows they cast were long, precise, and geometrically consistent with vertical structures of significant height. William Blair, an anthropologist and scientist working with the Boeing Institute of Biotechnology under a NASA contract, was among the first to formally analyze these formations. Blair made a statement that, in the context of 1966, should have detonated across every front page in the world. He said that the arrangement of these spires bore a striking resemblance to the geometric and statistical properties that distinguish artificially erected objects from naturally occurring geological formations. He was not speaking loosely. He was applying the same scientific criteria used in archaeology, the field dedicated to identifying deliberate construction versus natural erosion. And his conclusion, measured and methodical as it was, pointed in only one direction. These objects did not look natural. They looked placed. The structures became known informally as the Blair cuspids. And here is where the story takes the turn that separates ordinary scientific controversy from something far more calculated. The photographs were not suppressed immediately. They were initially released. They were analyzed publicly. Science magazine, one of the most rigorously peer-reviewed scientific publications in the world at the time, ran a feature on them in 1967. There was, briefly, a genuine open discussion in the scientific community about what these formations represented, and then, with a swiftness that defied normal academic timelines, the e-conversation was shut down. The photographs were reanalyzed by NASA, and a new official explanation was issued. The spires, NASA now said, were simply the result of boulders casting long shadows in low lunar sunlight. The geometry, the height measurements, the statistical improbability of their arrangement, all of it was quietly explained away. Blair's analysis was not refuted in any published scientific paper. It was simply never responded to. It was allowed to dissolve into the background noise of the space race, buried under the overwhelming spectacle of Apollo, and forgotten by a public that had bigger, shinier things to watch. But the Blair cuspids were only the beginning. Because what happened over the following decades, as technology improved, as independent researchers gained access to NASA archives, and as the lunar reconnaissance programs of other nations began returning their own data, was that the anomalies did not disappear. They multiplied. Consider what NASA's own Lunar Reconnaissance Orbiter, launched in 2009 with the most sophisticated lunar imaging systems ever deployed, found when it began systematically photographing the lunar surface at resolutions previously impossible. The LRO's cameras were capable of resolving objects as small as half a meter across. At that resolution, the lunar surface should have been an open book. And in many ways, it was. The LRO returned extraordinary science. It mapped water ice at the poles. It identified lava tube networks of staggering scale. It charted the lunar geology with a precision that transformed our understanding of how the moon was formed. But it also returned images that generated fierce, unresolved debate within the planetary science community. Images of linear formations. Eyes of structures with right angles and consistent geometric proportions that appeared, by every applicable metric, inconsistent with the volcanic and impact processes that govern lunar geology. Let's talk about those lava tubes, because this is where the story moves from historical anomaly into something that carries immediate present tense weight. In 2017, data from the Grail mission, two spacecraft that mapped the moon's gravitational field with extraordinary precision, confirmed what planetary scientists had long suspected but never been able to prove. Beneath the lunar surface, there exist tunnel systems of colossal scale, lava tubes formed during ancient volcanic activity, now hollow, stable, and vast. The largest of these structures, located beneath the Marius Hills region, is estimated to be hundreds of kilometers long and potentially more than a kilometer in diameter. To give you a sense of what that means, you could fit an entire city inside one of these tunnels. Not a neighborhood, not a district, an entire functioning urban environment protected from radiation, micrometeorite impact, and the brutal temperature swings of the lunar surface. The Japanese space agency JAXA, working from Kagaya orbiter data, identified a specific skylight, an opening in the lunar surface, that leads directly into one of these subsurface networks. They published their findings. The coordinates are known. The entrance has been photographed. And the interior of that tunnel system, as of this moment, has never been explored. Not by any publicly acknowledged mission, not by any rover or probe that appears in any official mission manifest. Think carefully about what that means. We have the technology to image this tunnel entrance in extraordinary detail. We have missions, Artemis, among others, that are specifically designed to return humans to the lunar surface. We have a stated objective of establishing a permanent lunar presence. And the one location on the entire moon that offers natural pre-existing shelter on a massive scale, the one location that would make human habitation on the moon immediately, practically feasible, that location has not been scheduled for any announced surface exploration. The silence around the Marius Hills skylight is not a logistical oversight. It is a deliberate, sustained, institutional decision. And the question of why, of what consideration could possibly outweigh the obvious strategic and scientific value of exploring that entrance, does not have a comfortable answer. Now, layer onto this, the Clementine mission. 1994. A joint NASA and Ballistic Missile Defense Organization project. And note that institutional partnership carefully, because it matters, that conducted a comprehensive photographic survey of the entire lunar surface. Clementine returned 1.8 million images of the moon. Of those 1.8 million images, a significant portion were released to the public. But researchers who have spent years cross-referencing the publicly available Clementine archive against the mission's known photographic coverage have identified systematic gaps. Specific regions, specific coordinates, sections of the lunar surface for which Clementine images should exist, based on the mission's documented orbital path and imaging schedule, but for which no images appear in the public archive. This is not a matter of data loss or technical failure. The gaps are too consistent, too geographically specific, and too precisely located over regions that have independently generated anomalous photographic data to be explained by random equipment malfunction. According to researchers who have formally cataloged these discrepancies, the missing coverage areas include sections of the far side of the moon, the hemisphere permanently turned away from Earth, and specific crater regions in the southern polar zone that have since been identified by other missions as locations of unusual subsurface density anomalies. The far side of the moon occupies a special category in this conversation, and it deserves careful, direct attention. Until 2019, no spacecraft had ever soft-landed on the lunar far side. The Chinese National Space Administration's Chang'e 4 mission changed that on January 3, 2019, when it successfully deployed the Yutu-2 rover onto the floor of the Von Karman crater, a structure more than 180 kilometers across, sitting within the South Pole Aitken Basin, the largest and oldest impact crater in the solar system. What Yutu-2 found in the weeks following its standard lunar regolith that covers the rest of the surface. The substance was photographed. The images were released, and then the official mission communications went quiet on the subject for an extended period, before eventually issuing an explanation that the material was likely melt rock created by a meteorite impact, that a number of independent geologists found inadequate given the described visual properties of the substance. The material has never been physically sampled. No further investigation has been publicly announced. The coordinates are known, the images exist, and the question of what Yutu-2 actually found in that crater is, at this moment, formally unresolved. But let us step back from the specific anomalies for a moment and look at the structural pattern, because the pattern is, in many ways, more revealing than any individual data point. What we are looking at across 60-plus years of lunar exploration is not a series of isolated mysteries. It is a consistent, repeating institutional behavior. Unusual photographic data is released, generates scientific interest, and is then explained away through official channels, not through the publication of counter-analyses in peer-reviewed journals, but through press releases and public statements that assert rather than demonstrate. Access to raw mission data is systematically restricted, with public archives containing documented gaps that cannot be accounted for by technical failures. Independent researchers who attempt to formally investigate these gaps encounter obstacles. FOIA requests that are denied on national security grounds, data requests that are technically fulfilled but return corrupted or incomplete files, and a broader scientific culture in which serious engagement with lunar anomaly research is sufficient to end a professional career. This is not the behavior of an institution with nothing to hide. This is the behavior of an institution that has learned with great precision and long practice exactly how much to reveal and exactly how to contain what it cannot reveal. The national security dimension of this story is something that mainstream coverage almost never addresses, and it is perhaps the most important key to understanding why the institutional behavior looks the way it does. The space agencies that have most extensively explored the lunar surface, NASA, and to a lesser extent its Cold War-era Soviet counterparts, were not, and have never been, purely scientific organizations. NASA was born from the National Advisory Committee for Aeronautics in 1958, 1 year after Sputnik, in the direct context of military competition with the Soviet Union. Its founding mandate was explicitly dual use. Civilian space exploration and national defense capability development were woven together from the first day of the agency's existence. The Clementine mission's partnership with the ballistic missile defense, current international framework is not equipped to manage. The classification decision is not made by scientists. It is made by people who operate in a very different institutional context, applying very different criteria, and those people do not give press conferences. Consider the Outer Space Treaty of 1967, signed by the United States, the Soviet Union, and eventually over 100 other nations. This treaty established the foundational legal framework for all space exploration. It declared that no nation could claim sovereign territory on the moon or any other celestial body. It prohibited the placement of weapons of mass destruction in space. And it included a provision, Article 19, requiring that any discovery of scientific significance made in space be shared with the international community. Now ask yourself this: if a mission funded by the United States government discovered something on the lunar surface that, if publicly revealed, would immediately trigger an international race to claim, control, or militarize it, something whose disclosure would create the kind of geopolitical crisis that the Outer Space Treaty was designed to prevent, what would the rational institutional response be? Silence? Reclassification? Official explanation? The same tools that have been applied, consistently and methodically, to every major lunar anomaly since 1966. The most recent chapter in this story is unfolding right now in the context of the Artemis program, NASA's stated mission to return humans to the moon by the mid-2020s, and to establish a permanent crewed presence on the lunar surface. The official narrative around Artemis is framed entirely in terms of scientific exploration, international partnership, and the practical development of deep space infrastructure. But the specific landing sites selected for Artemis missions, concentrated in the lunar south polar region, near the permanently shadowed craters where water ice has been confirmed and where subsurface density anomalies have been independently detected, are not explained solely by the scientific and logistical rationale that NASA offers publicly. The South Polar region is also, according to multiple independent analyses of LRO gravitational data, the area of the moon with the highest concentration of unexplained subsurface mass concentrations, regions where the moon is, for reasons that standard geological models do not satisfactorily account for, significantly denser beneath the surface than it should be. These mass concentrations, called maskins in the Iowa scientific literature, have been known since the late 1960s, when they were first detected by the gravitational disturbances they caused in the orbital paths of early lunar missions. Their existence is not controversial. What is controversial, what remains, after more than half a century of lunar science genuinely and formally unresolved, is what they are made of and why they are there. What most people are not seeing in the public conversation about Artemis is the degree to which the program's architecture, its timeline, its site selection, its infrastructure priorities, maps with uncomfortable precision onto the geography of lunar anomalies. The Gateway Station, which Artemis is designed to eventually support, will be placed in a near rectilinear halo orbit that provides optimal coverage of the lunar South Pole. The commercial lunar payload services being developed in parallel with Artemis include missions whose specific scientific objectives, subsurface radar mapping, gravimetric surveys, deep core sampling, are precisely the tools you would deploy if you needed to definitively characterize what is beneath the lunar surface in specific, targeted locations. This is not space exploration proceeding randomly. This is space exploration proceeding with a map. And the question of where that map came from, of what earlier data shaped the targeting decisions that are now driving billions of dollars of investment and the full institutional weight of the world's most powerful space agency, is a question that the public record does not answer. There are people who have spent decades working inside the institutions responsible for lunar exploration who have said, in various forms and with varying degrees of explicitness, that the public understanding of what has been found on and beneath the lunar surface is incomplete. Some have spoken through official channels, through congressional testimony, through published memoirs, through carefully worded statements and interviews conducted near the ends of long careers. Others have communicated through intermediaries, through the kind of carefully structured disclosures that leave the speaker protected by plausible deniability, while ensuring that the information reaches researchers equipped to understand its significance. The consistent thread in all of these communications is not a specific claim about alien megastructures or extraterrestrial engineering. It is something simultaneously more modest and more profound. It is the assertion that the moon contains features, physical, structural, geological features, that do not conform to the models of lunar formation and evolution that are publicly presented as settled science, that the gap between what is known internally and what is presented externally is large, and that the institutional mechanisms designed to manage that gap have been operating continuously and effectively for longer than most people alive today have been aware that there was a gap to manage. Here is the thing about silence at this scale. It cannot be maintained indefinitely. The technological barriers that once made it possible to control access to lunar imagery are dissolving. India's Chandrayaan missions have returned independent data. China's Chang'e program is operating with increasing sophistication and decreasing deference to the information sharing frameworks that once he gave Western space agencies effective monopoly control over the narrative of lunar exploration. Commercial imaging companies now operate lunar-capable satellites outside the direct oversight of any national space agency. The community of independent researchers with the technical skills to analyze raw planetary data and the platforms to publish their findings outside traditional peer. Reviewed channels has grown beyond any realistic capacity to suppress. The model under which inconvenient data could be quietly reclassified and replaced with sanitized alternatives, a model that worked extraordinarily well in 1966, reasonably well in 1994, and with increasing difficulty in 2009, is approaching its operational limits. Something is on the moon. Perhaps multiple somethings. The precise nature of those somethings, whether they are the product of geological processes we do not yet understand, whether they are the remnants of something that predates our presence in this solar system, whether they represent something else entirely that does not fit comfortably into any existing scientific or cultural framework, is genuinely formally unknown. But the structures exist in the photographic record. The anomalies exist in the gravitational data. The subsurface features exist in the radar mapping. The documented gaps in the public archive exist in the documented gaps in the public archive. And the behavior of the institutions responsible for lunar exploration, the consistent decades-long pattern of explanation without refutation, disclosure without transparency, and access without openness, exists in the institutional history of every agency that has pointed instruments at the lunar surface and found something it was not prepared to explain. The next human boots to touch the moon will land in a region selected by people who know more than they have said, at coordinates chosen for reasons that have not been fully disclosed, equipped with instruments calibrated to detect things that the public has not been told are there to be detected. And when those missions return, when the data comes back, when the samples are cataloged, when the subsurface surveys are processed, the question will not be whether something extraordinary was found. The question will be whether, this time, the world is told what it was. The moon is not what we were taught it is. The science says so. The photographs say so. The gravitational data says so. And the silence, that vast, structured, institutional silence that has surrounded the most anomalous discoveries of the space age for more than half a century, says so most clearly of all. The question that no one in any press conference, in any published mission report, in any officially sanctioned scientific publication has been willing to answer is not whether something is there. That question, if you follow the data honestly and completely, has already been answered. The question is, what happens to the world when the answer is finally, unavoidably made public? What changes? What breaks? What has to be rebuilt from the ground up? And who decided, 50 years ago, that humanity was not yet ready to find out? We may be about to learn whether they were right.